this video, we're going to be looking at electromagnetic waves, and this is video number 3 of 4 for our waves topic. So let's crack on. So electromagnetic waves are transverse waves which transfer energy. Electromagnetic waves carry energy from a source, like a light bulb, to an absorber, like a desk. Electromagnetic waves do not make matter vibrate like sound waves. Instead, they are oscillating magnetic and electric fields. But you don't actually need to know that. But it's good for context to know what electromagnetic waves actually are. Electromagnetic waves are actually split into what we call a spectrum. All parts of the spectrum have the same wave speed, but vary in wavelength and frequency. So we've got radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. The spectrum groups waves with similar frequencies together. The largest frequency is gamma rays, the smallest frequency being radio waves. Our eyes only detect a small portion of the electromagnetic spectrum, and this is called visible light, which makes sense. Light bounces from surfaces, and certain wavelengths bounce off and enter our eyes. We're now going to watch a video of quite a famous song. You may have heard it before, but yeah.
Electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. From the TV station to your living room, that is the work of radio waves. Heating food in just seconds, microwaves do that. Heat treatment for illness, take pictures in the dark. They are even in your remote control. Infrared radiation, the electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Red, orange, yellow, green, blue, indigo, violet. That is the only part of the spectrum that can be seen by us. The suntan on your skin kill bacteria and viruses. Used to detect forgery. That is ultraviolet. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. See your broken bones and your hidden bombs. That is the work of X-rays. Kill cancer cells and sterilize. Dangerous gamma rays do that. Now we have completed the electromagnetic spectrum. If you still do not understand, then play the song again. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, ultraviolet, X-rays, gamma rays, radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays.
There you go. I had to withhold myself from singing there. Very good song. Adele has nothing on that to show. Right, so you do need to know the different parts of the electromagnetic spectrum and what they are used for. So it's a good way of remembering it by remembering that song. But if you haven't really been paying attention to that, or you like to learn in a different way, don't worry. We will go over the uses of electromagnetic waves later on as well. So you also need to know about energy transfer and how electromagnetic waves can transfer energy from different sources and to different sources as well. So electromagnetic waves are essentially just light. Now light is a form of energy, so there are certain energy transfers that you need to know about. The sun is a massive source of energy. Electromagnetic waves, or electromagnetic radiation as it's also known as, comes from the sun after nuclear decay transfers nuclear energy into heat and light. All parts of the spectrum come from the sun, but mostly infrared, visible light and ultraviolet light. You can also get electromagnetic waves from nuclear decay. When a nucleus undergoes decay, a gamma ray can be released, as the energy from the nucleus needs to go somewhere. Gamma rays can be especially dangerous, so often you will see workers dealing with them wearing lead-lined clothing. You can also get electromagnetic waves from light bulbs. When a light bulb is switched on, electrical energy is transferred into light energy, an electromagnetic wave. As well as energy transfers from other energy sources, electromagnetic waves can transfer into different types of energy themselves. So in a microwave oven, for example, microwaves convert into heat energy. So the electromagnetic waves which are found in a microwave, which are microwaves, transfer their energy into heat when the microwaves come into contact with food. Because food particles or foods which contain water interact with the microwaves in a way which produces heat. And that's why when you put food in a microwave, it heats up, because the microwaves, which is a form of electromagnetic wave, hit the food and then the food warms up. If you're following along in your revision workbook, pause the video now and complete task number 7. Okay, now we're going to have a little look at how electromagnetic waves behave. Different substances may absorb, transmit, refract, or reflect electromagnetic waves in ways that vary with wavelength. For example, visible light reflects off of shiny surfaces but gets absorbed by black surfaces. Microwaves are another example. They get absorbed by molecules, particularly water molecules, but reflect off of metals. And gamma rays are much more penetrating. They transmit in more objects, so gamma rays can get through more objects. So, as we have seen from the previous slide, wavelength affects how electromagnetic waves behave. But so does wave speed. Refraction is caused by a wave speed changing as it enters a new medium, and we know all this from our previous videos. When an electromagnetic wave enters a denser medium, the light slows down. This means the light will bend towards the normal. Think of refraction of electromagnetic waves as a car travelling from a road into mud. The wheels on the left will be moving faster until later, and that means the car will be pushed at an angle. And you also need to know how to construct ray diagrams for refraction, but we covered all of this in a previous video. This is just to illustrate that all parts of the electromagnetic spectrum undergo the same processes that were learned for visible light. Here, wavefronts, which are parts of the wave which are all at the same point, are shown, and you can see that the waves bend towards the normal. You can imagine these lines as one long wave, like what happens in the sea. But again, we'll learn all of this in a previous video. You do need to know about how electromagnetic waves can interact and how that can be useful or be used in machines and things like that. So radio waves and electricity are related. Radio waves can be sourced from electrical circuits. When alternating current travels through a wire, the oscillations between positive and negative create radio waves at the same frequency. This is basically how radio works. A radio station sends AC current through wires which generate the radio signals. When radio waves are absorbed, they may create an alternating current with the same frequency as the radio wave itself. This means that when you expose metals to radio waves, an electric current may flow. This means radio receivers can change radio waves which have come from radio stations into electrical signals for speaker input. You can also get electromagnetic waves being sourced from changes inside of an atom. Changes within atoms can trigger electromagnetic radiation to be released, and electromagnetic radiation in itself can cause changes within an atom. When decay happens in the nucleus of an atom, gamma rays can be ejected. This is known as gamma emission or gamma radiation. And these waves can actually be quite hazardous. So electromagnetic waves which have a high frequency can be dangerous if they come into contact with your skin. As you have previously seen from the atomic structure topic, some types of radiation can cause problems with the human body. This includes gamma rays, but it is not only gamma rays which cause problems within the electromagnetic spectrum. Ultraviolet rays and X-rays are also harmful to the human body, and that's why when we go out in the sun we'll put sun cream on. The risk you have depends upon the type and the amount of radiation which you come into contact with. UV, or ultraviolet, X-rays and gamma rays ionise matter. This means it knocks electrons out of place, and this can have bad effects on your skin and internal organs. It can cause malignant cell growth, which is cancer. The types of radiation get progressively worse as their frequency increases. Gamma rays are the worst, and UV rays do the least amount of harm out of the three which do you harm. Radiation dosage, the amount of radiation which you are exposed to, is measured in sieverts. There are 1000 millisieverts in 1 sievert. Ultraviolet waves can cause skin to age prematurely and increase the risk of skin cancer. X-rays and gamma rays are ionising radiation that can cause the mutation of genes and cancer. A small amount of this radiation can cause cancer. A large amount can kill cells altogether. Cancer is a major risk when you receive high doses of radiation. So as you can see by this chart, as the radiation dose starts to increase, the amount of people who get cancer from being exposed to that amount of radiation also goes up. But most people are safe because they're around a small amount of radiation or background radiation where the cancer rate is relatively small. What conclusions can you draw from this graph? Well, let's test your knowledge, and you can complete task number 8 in your workbook now. Next, we're going to have a look at uses of electromagnetic waves. You need to know the uses and why specific types of electromagnetic waves are used in particular ways. Hopefully, from the song that we have already listened to, you should have a vague idea already. Radio waves are used for television and radio signals. Their long wavelengths mean they don't have enough energy to leave the close proximity to the Earth, so they can bounce around the atmosphere and can be received. Transmitters create radio waves and receivers pick up radio waves and transfer the signals into electric signals. Microwaves are used for satellite communications and to heat food. Microwaves have slightly more energy than radio waves, so can travel from satellites in space to dishes and supply us with television signal. Microwaves also interact with water molecules and give them energy, so foods with water within them can be heated in a microwave. Infrared radiation is used in electrical heaters, is used for cooking food, and is used in infrared cameras, or cameras with night vision. Infrared radiation is related to heat transfer, so using infrared radiation in cooking appliances, heat lamps and heaters is common. Our bodies emit infrared radiation along with black bodies, which we'll study later. So even when there is no visible light and it's dark, cameras can still pick up an image because it's picking up the infrared radiation instead of the visible. Visible light is used in communications as well as microwaves and radio waves. Fast internet uses fibre optics, which is light travelling through glass or plastic. Because visible light, along with all parts of the electromagnetic spectrum, travel at 300 million metres per second, signals can travel very quickly in fibre optic wires. This makes fibre optics popular for faster broadband. Ultraviolet light is used in energy-efficient lamps and in sun tanning. Ultraviolet light is suitable for tanning beds because our sun tans naturally to radiation from the sun. Part of this radiation is ultraviolet and is UV in particular, which causes the tanning, so UV light created artificially has the same effect. X-rays are used for medical imaging and gamma rays are used for cancer treatments. X-rays are suitable for medical imaging as they pass through soft tissue but can't pass through bones. This means that when projected from behind, X-ray images can show bones and broken bones and fractures can be identified. Gamma rays are good for killing cancer as many gamma rays can be fired at a tumour. Gamma rays are so energy intensive that they kill the cancer cells and stop them from spreading more. If you're following along in your revision workbook, pause the video now and complete task number 3.
Thank you very much for watching. Workbooks and test papers which integrate with these videos and online courses are available at our website, backroadtutoring.com.